This problem and all other Calc 135 problems can be found in Sarai Studies. Link is in the description box below. In this video, I'm going to talk about a few topics: the absolute extrema, critical points, and EVT, which is the extreme value theorem. So we have a bunch of graphs, and for the first one, we're going to go ahead and find the absolute extrema, which is just a fancy way of saying, hey, find the absolute max and absolute min. So we look at the graph and we ask ourselves, what is the highest point on the graph if we want to find the absolute maximum? Well, it's this point over here. So where is it located? It's located on x is equal to 3. So where is it? X is equal to 3. What is the actual value? What is the actual highest value? Well, it's not. That is the maximum value of this function. Now for the absolute minimum, you ask yourself, what is the lowest point on this graph? Well, I see the lowest point is over here. I know that that's located at x is equal to 0. This is x is equal to 0. And then the actual value is 0. This is also y is equal to 0. So where is the absolute maximum? Again, ask yourself, where is the highest point on this graph? Well, I see that the highest point is right about here. Because if we go ahead and kind of draw a line, we'll see that none of these other ones reach, right? It's only this one over here. That's the highest point. So where is that located? It's located at x is equal to b. And then the absolute minimum, ask yourself, where is the lowest point on this graph? If we kind of go and draw a line, I would say that the lowest point is over here at x is equal to a. Now here's where things get interesting. If we try to find the absolute maximum on this graph, we ask ourselves, okay, what is the highest point on this graph? Well, I see that it's over here, and I know that that is at x is equal to 0, because over here it's 0. But what is the absolute minimum? I ask myself, what is the lowest point on this graph? Well, I don't know, because this graph is not bounded. It keeps on going forever. And so the idea is that there is no absolute minimum. All right, so for the next one, we ask ourselves, where is the highest point on this graph to find the absolute maximum? Well, there is no highest point, because look, if we even draw a line over here, we have values of y that are higher than this one. So this is not an absolute maximum. But the point is that these values, we don't know what they are. They just keep on going. It's unbounded. And so therefore, there is no absolute maximum. What about an absolute minimum? I would say maybe this one, right? But if we draw a line, there's values of y that are even less than that one. No, it's not the most minimum point on the graph. There's other values that are less than that, but because it goes on forever, there's no bound, therefore there is no absolute minimum. For the next graph, we have something that looks like this. To find the absolute maximum, we ask ourselves, where is the highest point on this graph? Well, I would think it's this one, right? If we go ahead and draw a line through it, you would think it's that one because, you know, it is kind of the highest point, but it's not closed. We don't include it. It's not defined in this function, and so therefore there is no absolute maximum because it literally is not defined in this function. Same thing for the absolute minimum. Ask yourselves, where is the lowest point on this graph? I mean, you draw a line through, it's most definitely the lowest point, but it's not defined in the function. It's not included in the function, so there is none. So for the last one, where's the absolute maximum? Again, ask yourself, where is the highest point on the graph? Well, I would say that over here is the highest point of the graph. If you want to check, draw a line. Is there any other point that's higher than that? No. So the absolute maximum is at x is equal to b. Now, where is the absolute minimum? Well, where is the lowest point on the graph? I would say that it's here. You want to check, draw a line. Is there any other point that's lower than that line? No. Therefore, there's an absolute minimum at x is equal to a. So we just got done finding absolute extrema given graphs, but what if we're not given a graph? What if we're given a function instead and we're told to find the absolute max and min? What do we do then? We'll cover that in the next video.